Now we are going to start talking about the batch system, but I first want to see if I can somehow get access to Kebnekaise again, because otherwise I can't really show how anything looks. Okay, this seems still to be down. Let's see how ThinLink is faring. It seems that ThinLink is still up, so my guess is that it's the regular HPC2N Kebnekaise login node that's down. So I'm going to work on the ThinLink login node. I just want to see if my colleagues has said anything about why it's down.
I cannot see that.
Okay, you can log in to Kebnekaise.
Yes, I can log in, but to the normal thin link node, not the AMD.
Okay. Okay, I don't know what the problem is. I'm guessing that since you can log into some of them and I can log into some of them, there is something that's not working as it should. So I'm just going to go ahead and use the one that works for me on ThinLink at least, which is in any case weird. But okay. Okay, so I have the exercises here, and I hope you're able to log in either with the regular terminal or with the ThinLink. So let's look at the batch system then. And here we will quickly look at what is a batch system and which one is used at HPC2N. We'll learn some basic commands for the batch system used at HPC2N, how to create a basic batch script, how to manage your job, submit, find status, cancel jobs, check on jobs. Also learn how to allocate specific parts of the Kebnekaise, Skylake, Zen 3, Zen 4 GPUs, how to start a batch job or an interactive app through Open OnDemand desktop. So first, large, long, or parallel jobs must be run through the batch system. Kebnekaise is running a batch scheduler that is called Slurm. Slurm is an open source job scheduler. It provides three key functions. It keeps track of available system resources. It enforces local system resource usage and job scheduling policies. And it manages a job queue, distributing work across resources according to policies. So in order to run a batch job, you need to create and submit a Slurm submit file. When you Google Slurm submit files or look for something online, you'll find that some people will call it a batch submit file or batch script or job script. It's all the same. It's just different names for the same thing. If you start an interactive session through Open OnDemand, it also runs a batch job. That will start on a compute node, and we will look at Open OnDemand at the end of this session. So if you want more information about this, there's HPC2N's batch system documentation, and it's here. And there's a lot of information here that you can find. Okay, so some of the basic commands. If you use a job script, it's usually recommended to do so. If you ask for resources on the command line, you will wait for the program to run before you can use the window again. If you're using a batch script, that's not the case. Also, if you use a job script, you will have an easy record of the commands you used, so that when you want to run it again later, you can see how you did it earlier and edit it for how you want to use it later easily. So when you submit a job, the system returns a job ID. This job ID you can also get with sq So now in this following here, when it says job script in capital letter, that is the name that's supposed to go there for the job script. And job ID is the job ID for your job assigned by Slurm. Username is your username. So to submit a job, you would do sbatch job script. And to get a list of the jobs, sq minus u and your username, or sq minus minus me. Now let's take a look at one of these examples here. Let's take a look at simple. Inside simple, it's clear that we are running hello and in this allocation here. And that means that I need to compile hello, and I will just load FOSS 2023b, just like I did before. And I actually already have compiled this, but I'm just going to do it now just to see how it works. Oh, hello, like that. So now I have the executable hello that I need for hello.sh. So I'm going to submit it with sbatch, and it was called simple. And you see when I submit it, I get a return message, submitted batch job, and then a batch job ID. If I want to see which jobs I have running, I say sq minus minus me, and I have nothing running, but I'm going to submit this batch script simple a number of times, like that, and then let's see. Now I have several jobs here in the queue. Some are running R, and some are completing, and some are configuring, starting to run, and how long they run. It's a very short program, so it runs fast. So you can submit several of them in a way of actually getting something to look at with sq minus minus me. If you wanted to give the commands on the command line instead, you would use srun and the commands. And if you want to check on a specific job, you can do scontrol show job and then one of these job IDs. So I would say scontrol show job and then the job ID. And then I get a lot of information. I'm told what was the name of the job. I'm told it's completed. When did it start to run? How long was it allowed to run? How long did it run? How much? When did it start? When did it end? How long could it have run? Which partition did it run in? Which batch nodes? And so on and so forth. Lots and lots of useful information that we may ask of you if or look at if there's some problem with a job, because we want to check that it's not actually the node that has the problem instead. Okay, so let's imagine that you have submitted a job and it's sitting in queue, and while you're waiting for it to run, you realize that you had actually made an error in it and you want to make changes to it. Then you could delete your job with scancel and the job ID. Or if you have several of them, You can just cancel -u your username. That kills all your jobs. An interactive allocation, you can get that with salloc, but we recommend using Open OnDemand instead. You can get more information about your job with SACCT, -L -J job ID, and then telling it what you're interested in seeing to get, for instance, info on how much memory was used. And this is a very wide output, so that's why you put this pipe, and that means to send it on to other program. And we are using the program less with the option -S, which makes it sideways scrollable with the arrow buttons. It's maybe easier to see how it looks and what you should do if you look at the web URL with the graphical info about a job. And the job need to run at least 5 minutes or something. But then it will generate enough data that you have something to look at to see if it used maybe too much memory or something. And that is quite a good way of checking on your job. In general, you can always get information about a command by saying man and then the name of the command. So here is this example I just did. As you saw, there were some statuses. And R is running, CG is completing, that means the job is almost done, and CF is configuring the node. If it's PD, which is also common, that means the job is pending, for instance, sitting in queue and waiting for it to get allocations to run. In this example here, I all got them on this CPU Zen 4, which isn't altogether surprising. Because I also got them on the same node, because I have some nodes reserved, and it's very likely that they will go to that one. And because, well, that is the reservation that's made for this project. So when you do a batch script and you get some output, then you will usually, let's see, here. Usually it will go into slurm -jobid.out, and I probably got some of those, as you can see here. Slurm minus and then the job ID.out. But it will contain both output and any errors. You can look at the content with a regular editor, it doesn't matter which one. So I could, for instance, say nano, and then slurm minus, and then let's just take one of them. That. And then inside of it, it just has hello world, because that's the only thing output I had from that one. So if I had errors, maybe I wanted those to go to a separate file, so it was easier for me to look over it if I have a lot of output, and the same with output. And I can do that by adding to my batch script the command sbatch --error equals job dot %j dot err, and %j is an environment variable which contains the job ID, and if you use that, then you will not risk things getting overwritten, because it simply will get a new name each time it's run. For the output, I would say --output equals job dot %j dot out. You can name it what you want to, as long as you add the environment variable to make sure that you actually get a new name for each time it runs. Okay, we have now talked about running things and running job scripts. So maybe it's time to simply take a look at a job script. And these job scripts or job submission files, they can be very simple, where you specify almost all of it on the command line, or maybe it's several Slurm directives, comments, and executable statements. All of that is possible. And the Slurm directives are a way of specifying job attributes in addition to the command line options. When it comes to naming, name your script as you want to. It doesn't matter. That includes the suffix. It just is that you should name it so that you are able to remember what the script is for. And that when you come back and look over the directory, you can quickly find what is the job script. It's common to name it with a suffix of sbatch or sh, but it's not necessary. So first, you have this line here in the job script, a shebang, it's called. It tells the system that you are running in the bash shell. And that is important because that is the only shell that's completely compatible with the batch system, but it's not otherwise important. So just put the line there and you don't need to think further of it. So that should also be there always. Another thing that should also always be there is the account you're running in. It's mandatory. And it's this one here. In this case, it's HPC2N 2026 -002. Batch directives are always prefaced with hashtag sbatch, and it must be capital letter. And then you have -A telling it the account, project. Then -N1, that is how many cores you want to run in. And this is actually tasks, but since tasks per core is 1 per default, then this asks for 1 core. You can change it with -C if you want more tasks per core. Then you need to request how long the job should run. Hours, minutes, seconds, where 168 hours, that is a week, is the maximum. And in this case, here in this example, I'm asking for 15 minutes. Then I clear the environment from any previously loaded modules so that I don't have anything else loaded that might interfere. So I'm doing a module purge, and I don't want this to be in the output or in the error. So I just throw it to /dev/null, which is just a place you can put stuff so they go away in dev null. So it simply means that you don't want to see it in your output or your error files. And this tells it that it should take both the output stream and the error stream and put them together into this place. Then you need to load any modules you might need. In this case, I'm loading FUS 2023b, and then you can run your job. If it's a serial job, you can run it with // and then the name of it. Do note, these things, namely, as I said, batch, it must be capital letters. And if you want to make a comment, then the hashtag is used in front of a line to mean a comment. If it is instead of the hashtag sbatch directive, then of course there is already a hashtag, but you just put one more hashtag on it so that then it's commented out. And this I already mentioned, the project ID. And then you could have number of cores with capital N and number of tasks with lowercase n. And -C is cores per task. And you can use that to say if you want a specific number of cores allocated per task. It's useful for multi-threaded jobs, but it's also useful if you just want more memory, because maybe you just say that each task should use 2 cores, but only run on one of them. Then the other core is simply providing memory. Previously, I showed you a simple serial program. Now we have a simple serial program, a simple parallel program, an MPI program, and the only real difference here is that you are asking for more MPI tasks, and in order to run it, you run with the srun. So another reminder, if you haven't prepared the environment, if you haven't copied things, then you do so now. I'm going to assume you have. So let's go ahead and make a small preparation here and load FOSS 2023b if you haven't. Let's say ML. I already have it loaded. And then I want to compile the programs that I'm going to need in my batch script. So I already compiled hello. I'm also going to compile these 3 hello scripts. So I'm going to say MPI CC minus O MPI hello MPI MPI hello. I cannot spell today. .c and then MPI CC minus O MPI greeting. Okay, so now I have compiled those 4 programs. I can now run any of the following batch scripts directly because they all use these programs. And I could now submit any or all of these. So I'm going to submit MPI hello. Yes. And I am going to run one of these slightly longer ones. Multi-parallel ones. This one, let's take that. And then I will say SQ minus minus me. And then I can see that this longer one is actually running now. And now it has run. But this is some good example to get it to run a little bit longer so that you have time to see how they are behaving. And I think that you should simply try and do these exercises where you submit a few of these here and then you do S-control show job ID on a few of them and SQ minus minus me to see a list of them. And if you have time to do it before they finish, then do S cancel job ID for that job. And you could also see if it just uses Slurm minus job ID or if it actually is splitting them in 2. And if it's just using the first, then you should add these lines and see that new files are created when you submit them. So let's see, it's almost 12 o'clock. Okay, now I talked to some colleagues and they say that Kebnekaise login node had crashed and it should be up again and running, and indeed I could log into it, so I think that is correct. So I hope that people were able to actually submit anything either through the ThinLink login node or the regular login node. If not, it's possible to do so now. And yeah, I guess let's see what is in the one with the output here. Let's see. Separate error. Let's try open that and see. It needs MPI hello, so that should be fine. So I will submit that. And that should, when it's run, give us 2 separate files. Let's see if we got that. Hasn't finished running, I think. It should create one called job.out. It's there and it's there. Okay. So the error file has 0 bytes in it. There's no errors, and the output is this one. So let's see what's inside of the output. And it ran 8 times. And let's see what I had asked for. 8 tasks. So that was good. Okay, so let's instead continuing to the different parts of Kebnekaise. As talked about in the introduction, Kebnekaise is a very heterogeneous system with different types of CPUs and GPUs. And that means that the batch system uses different types of resources. At the top, we have partitions, similar to queues. It's made up of a specific set of nodes. At HPC2N, we have 3 classes of partition, one for CPU only, one for GPU only, and one for large memory nodes. Each of these types of nodes also has a set of features that can be selected, constrained which node the job should run on. And they also are corresponding resources to apply for in Super to be able to use them. So Kebnekaise has multiple partition, one for each major type of resource. However, the users can only submit to the partition batch. Some of the other nice systems are using partitions to separate with when you are asking where to submit to. But we are not doing that at Kebnekaise. We are instead using constraints. And the system then figures out what partition to send the job to based on the requested features or constraints. So we have that the CPU only ones, 3 types here. The types could then be Skylake or Intel CPU, or it could be Zen 3 or Zen 4, and you could get the Zen 3 and Zen 4 together as AMD CPU. The GPU-enabled nodes you can constrain with the types here. So V100, A100, MI100, A6000, L40S, H100, L40S, and then needs to be further constrained in order to get if it's this one or that one, and then also the A40 ones. In addition, there is the Broadwell large memory nodes. Sorry, I have something that itches my throat. So in order to target nodes in more detail, there are groups of features defined on each group of nodes. And these features or constraints are selected with the minus capital C option to S-batch or S-allocs. There are several reasons why you want to do that. It could be for benchmarks, it could be to replicate results, maybe specific modules are only available for certain architectures, etc. In any case, to constrain a job to a certain feature, you would use hashtag sbatch, remember capital letters, minus capital C, and then the type or the constraint. And these are the ones we saw here. So you can also combine them with the and with the or, and they should be wrapped in apostrophes. So if you want to say it can be either a send3 or a send4, then you write it like this. And here is the list of constraints that you could use for selecting a CPU and the ones for selecting a GPU. And for GPUs, the list of constraints can be either used as a specifier to GPUs equals type, one of these, colon number, that is the number of cards, or as a constraint together with unspecified GPU request. Minus minus GPUs equals how many, or GPUs minus per minus node equals number. There should be a minus minus in front of this. For some MPI jobs, MPI run may fail on some GPU nodes if you specify GPU with minus minus GPUs equals type colon number instead of using minus minus GPUs per node equals number. So it is safer to always use this one here. If you use srun instead of MPI run, there shouldn't be a problem. There are also possibility of selecting GPUs with certain features. Maybe you don't care what GPU you get as long as it's NVIDIA. Or maybe you want AMD. Or maybe you wanted to have single precision, double precision, AI features like half precision and lower, or machine learning features also half precision and lower. You can also selecting large memory nodes with large mem. Aside from using large memory nodes, if you need more memory, as I think I mentioned earlier, you can ask for more cores than you need and then only use some of them for running on, with the rest providing extra memory. So maybe you need 4 cores, but you need twice as much memory as the cores have. You can then ask for 8 cores and say you're using 2 cores per task. Remember, 1 is default. So ask for 8 and only run on half of them by saying 2 cores per task. The rest will be memory. So, just one moment. Did it stop sharing?
Yeah.
Yes, yes.
Weird. Okay. Here are some examples of constraints. If you only know, if say you only want nodes with send4 or send3 or Intel or whatever, you just give one constraint. If you want, for instance, a send4 CPU and a GPU with AI features, you could write it like this. Or if you want, for instance, either a Zen 3 or Zen 4. You can write it like this. So you can see it's possible to combine it in different ways. So let's look again at how to request GPUs. In order to use GPU resources, you have to explicitly ask for one or more GPUs. And that can be done either in total for the job or per node of the job. Say you want a GPU and you don't care what kind, then you would just do this or this. You may not want to do this because that means you could get either a AMD GPU or a NVIDIA GPU, and if you don't get an NVIDIA GPU, you can't use CUDA. So it's unlikely that you don't care about those two things at least. But so if you want to be sure that you get the type of GPU you want, then just ask for the number of GPU cards and then add the type. For instance, just constrain it to NVIDIA GPUs, or then you would be safe. Or you could say one of these types. One thing to pay attention to is when you are picking how many you want, you look at the list. That is up here somewhere. And see how many you could ask for at most. That is on this one here. So you couldn't, for instance, say, I want a node with A100s and I want 6 of them, because there are 2 GPU cards on each of them. So you can at most ask for the number of GPU cards. So if it's L40Ss, you could ask for 1 or 2, or actually you could ask for up to 6, because there are also some that are that. But do check how many there are of them. 2 is always safe because there are none of them that has less than 2 cards on them. Okay, so let's now move on to the Open OnDemand desktop and look at that some more. I already showed you how it looks and how to enter it, how to use the Kebnekaise desktop. And that it is very useful when you work interactively, because when you start it, it automatically runs on the allocated resources, which means that it's already running in your project. And you can work interactively without having to sit there and wait for each batch job to start. You can just work and still use your allocation. And as I pointed out earlier, there are these various settings, and we already looked at those, but I guess we can start it again and try ask for GPUs. I'll try and make a small example here. Let's see, this is, it's that one. Okay, yeah, I can do that. I will go again and ask for a desktop. And I will ask for a mate environment. It doesn't matter much, but I'm just running with that. And 2 cores is probably fine. And let's launch it. Shouldn't take long. Okay, now we have it. And then I'm going to start a mate terminal. I'm going to go to my project space. You can also click this one here that is That one will always be there. These are links I have made, but this one will always be there. And you can just go to, let's see, the file system, and then project, no backup. Let's find spring courses and your name, and then you could create folders or things like this here. So you could also do that if you wanted it this way. But this is the directory, yes. Okay, so now we have a desktop running here, and we have opened a terminal on it. And I'm going to go with this exercise here. Yeah, you can do srun bin hostname to see a list of nodes if you asked for more than one. And you can see you have 2 cores on this here because I asked for 2 cores. So this example, we will run the small Python program mmult.py. That is a matrix multiplication program for Python. And you can also see it here somewhere there. So let's start out by loading some modules. I'll just copy this here. And now we have loaded these modules. And I can run, for instance, this. Okay, let's do it that way instead. And you can see it's then doing matrix multiplication here. It will take a little while. When it has finished that, I am also going to try this example with Python and graphics, just to show that you could do that. There should be this Scottish Hills spreadsheet here. It's not finished yet. I'm just going to start another terminal. Let's try and see if this works, because I had some problems with it. The thing is, we have now changed the modules compared to what we had before. But let's try it out. Start Python. And I can probably just, well, let's just take them one at a time. So the only thing I want with this is to show that you can run a graphical program here, which I'm doing in a moment. Let's do the scatter plot. I'm a little bit surprised by how slow this multiplication here is, but shouldn't have taken that long. Anyway, here you can see that now, because you are working in a graphical user interface, you can open plots also within Python. So it's not like if you had a batch job, you were running the same thing, you could do that, but then you would instead have used plot.save, I think it's called, and then the name of a file that you wanted to put it in. So for something like this, it's nice. And it's also nice because you can simply run your program many times and make changes to it instead of each time having to sit and wait for the batch job to actually start. But I am going to go ahead and kill this for the simple reason that it's using 2 cores out of the ones that you can allocate in the reservation. And then I'm also going to quickly show how to open MATLAB, I think. Otherwise, there are links here to how you work with your own runtime environment for R or Jupyter with extra modules or MATLAB with multi-cores. We have written documentation for all of those cases, and you can play with those later if you want to. But I'm just going to start a MATLAB session also, just to see how it looks. And in this case, I'm going to ask for a GPU. And then I am going to take this one here and start it in that and launch it. It is now talking to the license server also, but it seems it already has done so. But it usually takes a couple of minutes for it to start MATLAB. Don't be concerned about that. Okay, so now you can work with MATLAB, and these things you run here, they will already run as a batch job within it, and you can make changes to it, so just like before. So that's nice, and yeah, there are exercises, and you can play later today. There may be exercises in the MATLAB section if anyone is interested in that. So when do you want to use Open OnDemand and when do you want to use a regular batch script? Well, Open OnDemand is good for the shorter things you want to run, if it's less than 12 hours, and things that needs a lot of interactivity or interactivity in general, or for graphics. Whereas batch jobs are better for longer jobs or for very parallel jobs that have more than 28 cores, for multi-step jobs and workflows, or any job in general that runs on its own without input. So the key points of this section about batch system is to submit a job. You first need to create a batch submit script, which you submit with sbatch submit script, whatever the name you gave your submit script. You can get a list of running and pending jobs with sq --me. Kebnekaise has many different nodes, CPU and GPU. You can constrain the job to run only on specific types of nodes. If your job is an MPI job, you need to use srun or MPI run in front of your executable in the batch script, unless, of course, your software handles the parallelization itself. Open OnDemand desktop is also using allocated resources. Anything you run there is run directly on the allocated compute nodes. And Open OnDemand is good for interactivity, and it's also a simple way to allocate resources because you don't have to write a batch script.